Hi guys, thanks for tuning in again. And today we're going to take a look at how we can render out a triangle on our screen using WebGL. So stay tuned. In this tutorial and in all future tutorials, all of the 3D objects that we're going to render will consist of triangles. So first we must define what a triangle is. So every triangle has 3 vertices, and each vertex is made up by 3 components, one x component, one y, and one z. We're going to take these components and concatenate them to a float array, which we're going to call the vertex buffer. Then we must tell OpenGL how this triangle is going to be rendered by defining an index buffer. The index buffer is also an array and will be constructed using integers, where each integer corresponds to the index of that specific vertex. So inside our init file, we'll first remove the request animation frame functionality and also the red animation, and maybe we can even get rid of the render function for now. And then we want to clear it with let's say a white color. Great. And now we're going to create a new folder, and we're going to call this models. And inside of here we want to create another folder called model type, and we're going to import create an index.js file here. So the first thing we need is the GLC, of course, so import GLC, and it's 2 steps out, and then GL commander. And now we're going to create a class, default class called model type. And inside of this class we need a constructor, and in this constructor we're going to take in the vertices of the triangle and also the indices. And then we want to bind them to this class, so vertices, and the same with the indices. Then we want to create a function called genVertexBuffer, and inside of this method we're going to create a buffer. And a buffer in OpenGL is basically a thing that you can allocate memory on the graphics card. So this.vertexBuffer is equal to glc.createBuffer. And this glc method here is something we're going to create in the GL commander later. And then we're going to call glc.bindArrayBuffer. And this is basically a function so that we can read and write to the buffer or the memory, and just pass in the vertex buffer in that. And then we're going to call glc.addArrayBufferData, and this will actually take in the vertices which we got in here in the constructor. And then we want to unbind the array buffer because we don't want to manipulate it anymore. Then we're going to do the same thing for the index buffer. So gen index buffer, and we're going to say that this.index buffer is equal to glc.createBuffer. Then we want to call glc.bindElementArrayBuffer because this is a different buffer. It's an int buffer, and this is a float buffer. So we're going to create 2 different methods inside the GLC, and we're going to pass in this.vertex index buffer here. Then we want to call glc.addElementArrayBufferData and just pass in the indices. And then finally unbind this, so unbind element array buffer. Great, now we can use these in the constructor. So this dot generate vertex buffer, and we also want to generate the index buffer. So let's go into our GL commander now, and we're going to create a method called createBuffer, and this is going to be a function that we're going to call an OpenGL command called createBuffer, and this basically returns the buffer as well. Then we can just make a comment here, and so we need to separate these. So we want to create the bind array buffer, and this takes in the buffer that we just created here, and then we want to call gl.bind buffer, and this will take in the array buffer constant from OpenGL and also the buffer that we passed in here. Then we want to create the unbind array buffer, and this basically calls this.gl.bind buffer, and the same thing here, but the value will be null. And then we want to add the add array buffer data method, and this takes in the vertices, and we're going to call this.gl.buffer data, and we're just going to use the array buffer again. And then we want to create a new float32 array and throw in the vertices here. And then we're going to call this.gl.static draw. Now for the int buffers. So int buffers, no caps, int buffers. We can basically just copy this. And now instead of having the names here as bind array buffer, we're just going to throw in element in between here. So element and element. And then we just want to add element here as well with capital letters. So element, and then we can just copy and paste these here. And now we also need a uint16 array here. And this, I'm going to rename this to indices. So that's great. So now we're going to talk a bit about shaders. So what a shader basically is a OpenGL program that runs in the GPU that we're going to upload. And there are two types of shaders that we're going to use for this tutorial. One is called the vertex shader and one is called the fragment shader. So the vertex shader basically takes in the positional data and it outputs that to the fragment shader, which then can take in its own parameters and do some color calculations and actually render the scene. So in order to get this to function, we must first create a new folder, and we're going to rename this, I'm going to name this shaders, shaders, there we go. And then we're going to create a new shader called a model shader, and inside of here we're going to create an index.js file as usual. So inside of here we want to import GLC, and then we want to export a default class, and we're going to call this model shader as well. And then we need a constructor. So inside of here we want to first create a vertex shader and then the fragment shader, but in order for us to do that we must create those files here. So we're going to create one file called vertex.js and one file that is called fragment.js, and we'll also need to create another file called locations.js. So if we go to the vertex shader, we can start off by importing locations. And then we need to go into the locations folder, and we're just going to create a enum variable here. So export default and then an object. And then we're going to create a position. Yeah, that's typed correctly. And this is going to be like that. And we're going to use this inside of our GLSL shader. So we can save this, go back to the vertex shader, and inside of here we want to export a string which will contain all of our shader code. So first of all, we're going to create an attribute. And an attribute is actually a value that you can pass from the CPU to the GPU. So we're going to do that now. And the thing, we want to name this locations.position. So that will actually take the value of the position here. So we're going to pass in a vec3, which is actually the vertex. Then we want to create the main function of this shader, which will actually execute everything. And then we can type GL position is equal to a vec4, and we can just throw in the position and 1.0 at the end, because we only have a vec3 here, so we have to add another number. And instead of doing that, we can just throw this in here as well, just to be consistent. Then we want to head to the fragment shader, and I've typed this wrongly here, so in fragment.js. And inside of here, we want to export defaults, just a string. And we're just going to create the main method here as well, main. And this will take in a frag color is equal to also a vec4, because we have RGB and A values here. And we're just going to set this to white for now. And let's say 1.0. So it's fully transparent and a white color. So that's the color of our triangle. Now, when this is done, we can go into our index.js file again. And we're going to construct this. So we need to import the vertex source from vertex file, and also the fragment source, like that. Then we need to import locations as well, because we're going to refer to that position enum variable that we created. So now in the constructor here, we want to first create a shader. So vertex shader is equal to glc.create vertex shader. And when that is done, we want to call glc.add shader source. So we're going to add the code we just wrote in the vertex source here to this newly created shader. So first of all, we're going to pass in the vertex shader and then the vertex source. When that is done, we want to compile this shader to make sure that everything has gone well and upload it to the GPU. So glc.compile shader, and throw in the vertex shader here. Now that's it for the vertex shader. Now we need to do the same thing for the fragment shader. So we need to rename everything here to fragment. And then use the fragment source here. When this is done, we want to construct a program which basically takes these two shaders and links them together. So const program is equal to glc.create shader program. And then we want to attach these shaders to that program. So attach shader to program. And what we want to attach is first the program, and to the program we want to attach the vertex shader. And then we want to do the same thing for the fragment shader. And then we have to link these together. So glc.link program. And just throw in the program. And then we're going to say that this dot program is equal to program, because we're going to use this program later on. So you remember that we just created the position thing inside of our vertex shader here, and now we need to refer to that in the shader programs here. So we're going to create a new variable called this.position attribute, because as we saw, it was an attribute. We're passing something into the shader. So glc.getAttribLocation, and then we're going to call locations.position. So now we're extracting the location of this position, and now we can use it later on when we want to render something. We're also going to create two more methods here. One is going to be called use. So to start using this shader, we want to call glc.useProgram, and we want to refer to this.program. And then we want to create another one called enablePosition, because if we want to use the position object, we have to enable it first. So glc.enable vertex array, this.position attribute, and then we want to call glc.point to attribute. And for now, I'm just going to pass in a 3 there, because these are the dimensions. So our triangle basically has an x, y, and a z component, and that is 3 dimensions. So we're going to pass this in to the method we're going to create in GLC. So that's the next thing we need to do. So if we head back to our GL commander, we can go ahead and create some new functions here. So we're going to label them shader functions. So we have create vertex shader, which basically calls this.gl.createShader with the argument this.gl.vertexShader. Then I want to do the same thing for the fragment shader. Fragment shader, and just replace the vertex here with fragment. So these two methods can create our different shaders. Now you remember we had an add shader source function, so add shader source, which basically takes our shader code in the vertex and fragment files and uploads them. So this needs to take in the shader and the source, and it will call this.gl.shaderSource with the shader and the source as arguments. Then we want a compile shader method, which takes in the shader, and it's going to call this.gl.compile shader. Then we want to create a shader program, of course. So create shader program, and this will call this.gl.createProgram. Then we want to be able to attach the shaders, so attach shader program. Like that, and we want to attach the, let's see, program and the shader, and we're just going to throw them in here. And then we want to be able to link the programs. And what we need to do is to pass in the program and call this.gl.linkProgram. And after that, we also need the use program. So use program. And this needs to be inside here as well. So really nice. Let's see if I've missed anything. I don't think so. Well, we have the enable vertex attribute array and point to attribute, so we need those as well. So get attribute location, which takes in the program and the attribute, and in our case that's the position. And this will take in the program and the attribute like that. And then we want the enable vertex attribute array function. Takes in the attribute and call this function on the GL context. So attribute. And then we also want the point to attribute function. So point to attribute, and this takes in the data and the dimensions, which we talked about earlier. Dimensions. This.gl.vertex attribute pointer. So the first argument of this is the data. The second one is the dimensions. Then we need to define what data type this is, and this is a float. Then we want to pass in false here, and then 0 for the stride and 0 for the offset. So you don't have to worry about these parameters. So basically the offset is that you can define where you want to start your rendering from, so you can offset it. Nice. So that is basically it for the shaders. Now we want to create a renderer for this. So render, a new folder. Inside of here, let's create a new renderer called model renderer. Add an index.js file here. And we need to import GLC. We also want to import the shader we just created. Shaders / model shader. Then we want to export this defaultly, default model renderer. And we need a constructor. And we need to add a class, of course. So this.shader is equal to a new shader. And then we need a render method. So inside of the render method, this is not a React render, of course, but we're going to name it render anyways. And then we need a pre-render method. What will happen before we render everything? And basically what we need to call is dlc.viewport, and we're going to create this. It's basically to tell OpenGL to render the entire canvas or a part of it. You can choose whatever you want, but I'm going to define it as full screen. Then we want to depth test, to add the depth test here, because otherwise the different objects in your scene will overlap each other, because they won't understand what the set value is, basically. But that's for the future. So inside of this render method, we want to call this.pre-render first of all. Then we want to call this.shader.use. And now we're going to define the things we're going to render. So in the constructor, create a new variable called models. And then we want to create a new function called register new model. This will take in a model and an identifier. So first we want to check if this.models of the identifier does not exist. Then we want to create it, so id is equal to a new object where the type is the model and the we're going to have an array of instances of this model. So inside of the render method, we're going to loop through each model type and upload its specific data to the GPU. And then we want to do another for loop inside of that, rendering all of the instances of this model. So then we need another function called add instance. So this will take in the instance and the identifier. So this models of that identifier dot instances dot push this instance. Now we can go back down to our render function, and inside of here we're going to do an object.keys of this models, and then we want to loop through each specific model type. So model and inside of here we're going to do this models of the model type use, and what we're going to use is this shader. So if we go back to the model type, you can see that we don't have that function yet, so we're going to create that now. So inside of here at the bottom we're going to define the use method, which will take in the shader. So glc.bindArrayBuffer, and what we want to bind first is this vertex buffer. Then we want to call shader.enablePosition, and that is the function we created inside of here. So enable position, and then we want to call glc.bindElementArrayBuffer. We're going to pass in this indexBuffer. So now we have bound and uploaded both of these buffers to the graphics card before we render. So go back to the render class here, and we're going to call this models of the model instances for each instance. And now we want to render this instance of this model. So glc.draw triangles, this models of the model type indices length. And now we're going to create these extra methods inside of the GL commander, which I just showed you that we typed. So inside of here at the bottom, let's create a draw triangles method, which will take in the number of indices. So this .gl.draw elements. So this function here is used to actually draw something with an index buffer. So this .gl.triangles, and we're going to pass in the number of indices, and the type will be this .gl.unsigned short, and I'm going to pass 0 as an offset. And one final thing we actually need is the viewport and the depth test. So we're going to put them up here. So viewport, this .gl.viewport, and we're going to start in the top left corner, so 0, 0, and we're going to go to the full width and height of the canvas. So this .gl.canvas.width and this .gl.canvas.height. And the final thing is the depth test. And actually we're going to pass in a parameter here. So if we want to use the depth test, then we need to create a ternary expression. So this .gl.enable this .gl.depth test, or if it's disabled, we want to this .gl.disable depth test. So that is basically it for the coding, and now we want to add it to the init method, of course. So in order to do that, we can go to our init file folder, and then we want to import the model renderer from render/model renderer. We also want to import the model type. So from models and model type. Great. So now in the bottom here, after the GL init, we want to initialize everything. So first of all, we need some vertices. We need to define them. So const vertices is equal to a new array. And we're going to specify the coordinates for this triangle. So 0, 0.0, 0.5, and then for the z value 0.0. And you can just copy and paste these, because I'm going to add them to the description. And then 0.5, minus 0.5, 0.0. And then the indices. So we're going to render 0, the first vertex is connected to the second one, which is connected to the third one. So that is basically our base for the triangle. And now we need to initialize the model renderer. And then we want to call the register new model function. And we're going to create a new model type. And we're going to throw in the vertices and the indices to this. And then we want to give it a unique key, an identifier basically, so triangle. And now we want to create a new instance of this. So model renderer dot add instance. And we're going to add, for now we can just add whatever we want here as the first argument, because we haven't created an instance yet. And in the future, an instance will basically consist of a transformation matrix and a position, so that we can move things around. And this needs to correspond to the triangle. So same IDs here. And now to render this, we can simply call model renderer.render. So hopefully now, if everything has worked out, we can see something on the screen. And we can't, of course. So something is wrong. Attach shader program is not a function. Okay, so let's go back to the model shader. Attach shader to program. So basically, I think we have, yeah, we misspelled that. Let's try it again. And we can't see anything because the background is white, of course. So let's go back to our shader code, to the fragment shader, and we can set this to maybe red. So 0.0 and 0.0. And then I saw another mistake, and that is in the init file. We cannot clear after we've rendered, then we won't be able to see anything at all. So if we move that to the top before the render, now if we save and try this out, and we can see a triangle. So that is really cool. And what I did in the intro was basically to set the color to the position, which creates some different gradient colors, and we can do that as well. So if you go back to the vertex shader, we can create something called a varying variable here, and we're going to name this color, and we can set the color in here to the position. So now if we go back to the fragment shader, we can use a varying variable here as well. And that has to be called the exact same thing as in the vertex shader. And we can just pass this in here. And then we also need to define the precision here. So precision is going to be a medium p float. and this needs to be defined in both the fragment shader and the vertex shader. So now if we run this, we can see that we have the exact same triangle as I showed in the intro. So thank you for watching, and next time we'll be taking a close look at how we can render a cube in 3D space. So thank you, subscribe if you want to, and like my videos, and I'll see you next time. Bye!